Okay, example 10 is another strategy for getting the square roots out of the bottom of a fraction, but this is what we have to do if we are either adding or subtracting something in the bottom of that fraction, and we can't just get rid of it by multiplying, but by multiplying by simply the square root. So we are multiplying by what's called the conjugate, which is essentially just the bottom part of the fraction, but we're going to change the sign. So here, if I have b plus the square root of c in the bottom, I'm going to multiply by b minus the square root of c over b minus the square root of c. And the reason for that is because when we multiply those together, we end up getting b squared minus b times the square root of c plus b times the square root of c minus c. And that ends up canceling out our middle terms for the multiplication. Now, if you'd like to see that broken down, just let me know and I'll be happy to show it to you. But the reason we multiply it by the conjugate, by like the opposite sign, is so that we can cancel out those middle terms. So that leaves us with b squared minus c for the bottom part of our fraction here. So, for example, if we have 3 over 4 plus the square root of 7, if I want to get rid of that square root, I can multiply by 4 minus the square root of 7 over 4 minus the square root of 7. Again, we're doing minus because this is plus. We're kind of doing the opposite here. So that would give me 3 times 4 minus the square root of 7 over b squared, where this is going to be the b, so 4 squared minus 7. Because the square root of 7 times the square root of the minus square root of 7 will give me minus 7. Again, if you want to see more of that, I'm happy to show you. We just don't have the space on this paper to do it. So this will become, if I multiply the 3 times 4 times the minus square root of 7, this will become 12 minus 3 square root of 7. And then 4 squared minus 7, that would be 16 minus 7. I can keep going with this a little bit, simply because the 16 minus 7 is a subtraction that we can do. So this would give me 12 minus 3 square root of 7 over, what that saves, over 9. And then I can actually simplify this a little bit more because each of these numbers is divisible by 3. So let's see if I can fit that in here. 12 divided by 3 would be 4 minus that 3 root 7. If we divide by 3, will become just 1 root 7 over 9 divided by 3 is 3. So we get 4 minus the square root of 7 divided by 3. Okay, so let's look at another example here. I have 4 minus the square root of 5 on the bottom, and so I'm going to multiply this by 4 plus the square root of 5, using the opposite symbol here that we have in our fraction. So 4 plus the square root of 5. So then when I multiply these, I would have 6 times 4 plus the square root of 5 on the top. And then we're going to end up with the b squared, which again, in this case, will be 4 squared minus c, which in this case is 5. So this gives me, let's see, 6 times 4 is 24, plus 6 square root of 5 over 4 squared is 16 minus 5. And I can again do this subtraction here on the bottom, 16 minus 5. So we would get 24 plus 6 square root of 5 over 11. And this one we won't be able to simplify any further because there's no number besides 1 that all 3 of these are divisible by. So this will be our final answer here. And that will be all for example 10.